In this video we're going to look at drawing an external straight line tangent between two circles of different sizes. So in our question I've got two circles. I've got a small circle with radius s and a large circle with radius r. I want a tangent that is going to be external to both of these, so it'll either touch it running along the outside here or running along the outside here. If I was referring to an internal tangent, it would be coming in the space inside the two circles. This is external. So what we need to do here is we cannot draw a tangent between a circle at this point. What we need to do is we need to reduce down the size of these into something that we can do. And in a previous video I showed how to draw a circle or a tangent to a circle from a point that's not on the circle. So we know how to do that, and we're going to apply that information here to solve this question. So if I take my large circle and my small one, how can I turn one of them into a point, into something that I do know? So if I can turn one of these into a point and a circle, I can solve this question. So if I take circle S and I reduce that size down, I'll be left with a point. If I do to 1, I need to do the same thing to this one. So I'm going to reduce the large circle down by the radius of S. So if I measure the radius of S, and I'm going to mark this here, so this distance is now over minus S, and that's the size of the circle that I'm going to draw. So now I can draw a circle that is that big, and now I have got a point and a smaller circle with radius r minus s. So the big radius minus the small radius. Now I have a point and a circle, which means I can solve this question doing the information that I have from drawing a tangent between a point and a circle. So I'm going to do what I normally do. I join the point to the center of the circle. And I need to bisect that line. So extend over halfway, swing an arc. There's one arc. Point my compass on the center of S. And swing the same size arc. Must be the same size arc. Drawing a line now that will join these 2 points. I get this point here. That is halfway between the center for this point and the center for this circle here. Now all I'm going to do is I'm going to swing an arc that is going to cut the small circle that I've drawn, r minus s, so swinging that here. That gives me what would be the point of contact for if I was drawing a tangent from that new circle that I drew down to point over here. That's not what I'm looking for. I need to extend this back out. So my tangent is going to be perpendicular to a line drawn here, so it will be perpendicular to the normal. So if I extend a line from the center through that point of contact that I found, this gives me the point that I'm looking for out here. That's one point of contact. My tangent is going to be perpendicular to it. So what I need to do is I need to find that same normal on the other circle, circle S. So using sliding set squares, find that same normal. So a normal being a line that's perpendicular to both, or to a tangent. This is my other point of contact, and I can draw my tangent. So, quick recap on what we've done. We started with a small circle, and I had another large circle. I needed to reduce the small one down to a point, which I've done. So when I remove the radius off this one, I need to remove the same size of radius off the large one, so I'm left with a circle that is this big. So take an S, minus it off this radius, so I must start from the outside and work in, left with this one. Now I have a point where I can draw a tangent from a point to a circle, join from a point to center and bisect, swing an arc so that it touches the outside of my circle, giving me what would be the point of contact between here and this point. My normal is going to pass through that point from the center for the larger tangent, giving me the position. That's one point contact. My other normal from the other first circle is going to be parallel to this normal, and then that gives me my other point contact, and now I can draw my tangent. There would also be a second tangent on the opposite side of this here, extending from the point through my point contact to a point out here somewhere, and that would also go back, joining back this way.